Alright, so today we are going to talk about Common Core Standard F, which is functions, and we're doing trig functions for. So we're going to basically use the unit circle, which is what we're doing, the unit circle, to graph periodic trig functions. Periodic trig functions. So in our reading, we talked about the graphs, and we went through and we graphed the sine and the cosine. And what we had, if I can find it, what we ended up getting is a trig graph, right? And that is a function, right? So we could write this as f of x is equal to sine of x. And it is a function, passes the vertical line test, right? We made this graph from the unit circle, didn't we? So let's take a look. Example 1. So what I want to do is take and graph my sine curve. We're going to call it a sine curve now. This is my sine curve. The only difference I'm going to do is this one has an amplitude of 1. I'm going to rewrite this one with an amplitude of 2. So it's going to be the exact same graph, except for I'm going to bring it up to 2 and down to -2. That's all. So when I do these, I like to go every 4 squares, pi halves. Every 4 squares, 1, 2, 3, 4. Pi, 1, 2, 3, 4. There's 3 pi halves. 1, 2, 3, 4, and make it 2 pi. When I do this, and you're gonna be try and do this. Try and go every 4 squares, and there'll be a reason for that later on when we start to squish them and stretch them. Okay. I need to go up to 2, so if I make this be 1 and make that be 2, and I can select the scales I want. Okay, -1, -2. Okay, so all I'm going to do is take this graph and go up to 2 and -2. That's all I'm going to do. So I know sine starts at 0. I know at pi halves, it's at its highest spot, right? At pi halves, it's its highest spot, so instead of going to 1 at pi halves, I'm going to go to 2. That's all. Okay. I know pi, the sine curve is at 0. At 3 pi halves, it's at its minimum at -1, but now I'm going to go to -2. And at 2 pi, it's 0. So here's my curve. Pretty easy. Technically, it continues going on. Think of it as a wave in the ocean. It continues to roll and roll and roll, but we need only just one full curve, okay? All right, example 2.
What's the period of that?
The period, thank you. The amplitude is 2. You guys agree with that? And the period is 2 pi. 2 pi because the width of one full curve is 2 pi. All right?
Is it always 2 pi?
No, we're going to change it coming on the next one. Good question. Okay, example 2. Am I good for example 2?
Yeah.
Yes.
So example 2, so I'm going to take my cosine curve right here, and instead of going up to 1, I'm going to go to 3 and -3 because the amplitude is 3. So let's go, maybe I could go, call it 1, 2, 3. I'll just go by 1s, 3, 1, 2, 3, and I'll call it -3. Okay, I'm going to do that first because I know the amplitude is 3, okay? And then the period. Now here's the thing. Everybody's got to listen to this. I need 2 curves. I need 2 curves. So instead of having one cosine curve, I need 2 curves. In order to get 2 curves, I've got to make it half as wide to fit 2 in there. I'll say it again. I need 2 curves. I need 2 curves, okay? The full curve is 2 pi, but I'm going to take that, I'm going to cut it in half so I can get 2 curves in the space of 1. What does that mean? My period now is pi for one curve. And then I'll draw the second curve, and the 2 curves together will make 2 pi, but I'll have 1 curve, 2 curve, okay? Probably need to expand this. So let's go and do our pi halves, pi, 3 pi halves, and 2 pi, all right? So on the side, I'm just going to go ahead and draw. This is the shape of a cosine curve, right? It's kind of what the shape of it is, right? From beginning to end. And I need to take this shape and fit it between 0 and pi. And then take another shape and fit it in between pi and 2 pi. To get two of them, I got to go one here and one here, and we'll get two. So if I take this shape and put it between here and pi, it starts up at 3. The shape starts up at 3, and it ends at 3. So I'm going to put the other dot here at pi because I'm going to put this shape here between 0 and pi so I can get two of them in, okay? Here at its minimum, it's going to be down here at pi halves, right? Its x-axis is 1/4 of the way through, and its other x-axis is right here 3/4 of the way through. So I get one curve. It has a period of pi, goes from 3 to -3. Now, let's get the second one so I can get two of the curves, okay? So the same thing, same shape. Starts at 3, it's going to end at 3. Its minimum is going to be halfway through. In this case, it would be 3/2. 1/4 of the way through, it's going to go through x. 3/4 of the way, it's going to go through x again. And this is what it looks like, okay? We have two full cosine curves within 0 to 2 pi. That's what the 2 stands for. I have two curves. I have two curves where I had one, okay? In order to get two curves, we had to make it half as wide. So I took the normal period and divided it by 2. So I divided up. Say how many? Okay, how big is one curve? The amplitude is pi. Okay.
So the period is on like where the curve ends rather than how long the graph is.
No, it is how long, but both go together. Okay. So it is. So it starts here and ends here, right? And what's the width of that? So it does. So one full curve goes here. How wide is that? Pi. 1 pi. There you go. So both, what you said is correct on both cases. You have to see where it ends. How wide is that? That's your period. How wide is it? Okay. All right. Number 3. So there's two things that are going to happen here. First of all, it's going to be upside down from 4 to -4. So the amplitude is 4. Somebody said it's the absolute value. Who said it was the absolute value of the amplitude? Okay, somebody said absolute value, right? Has to be because amplitude is, you know, a wave, okay? So the amplitude is 4, but this one's going to be upside down because of the negative, right? Do we agree? The negative is going to make it upside down. So again, let me go ahead and draw my cosine curve in, but I'm going to draw my cosine curve upside down. So I'm going to draw, it's going to look more like this. Okay, there's one cosine curve, but just upside down. Okay, if I got a general shape, that's not a very good picture, but we got the idea. Now, I need 3 of them within 2 pi. So here's how I do it. I take my normal 2 pi. That's one full cosine curve. I'm going to divide up into 3 parts, okay? Divide it into 3 parts. So the period of one curve is going to be 2 pi divided by 3. Take my normal period, and I have to divide it up into 3 curves, right? So that means one curve has to fit in between 0 and 2 pi thirds. So instead of going by pi halves this time, I'm going to go by thirds. I'm going to go by thirds. So let's make this pi thirds. 1, 2, 3, 4. 2 pi thirds. 1, 2, 3, 4. 3 pi thirds or pi. 1, 2, 3, 4. 4 pi thirds. 1, 2, 3, 4. There's going to be 5 pi thirds. 1, 2, 3, 4. 6 pi thirds or 2 pi. So I'm going to fit within this graph 1, 2, 3 curves. Okay? I'm going to get 3 curves in here. So first of all, let's just draw the first one. So the first curve is going to look like this, and it's going to be between 0 and 2 pi thirds. Okay? It's going to have a height of 4 and -4. Okay? So let's just take this shape, put it over here.
Let's do it.
Okay? 1, 2, 3, 4. There's -4. 1, 2, 3, 4. There's +4. So it starts at -4. It's going to end at -4. Okay? So I'm going to put a dot here and a dot here. The maximum is going to be in the middle, which is up at pi thirds. I'm going to have the x-intercepts a fourth of the way through and 3/4 of the way through. So I just graph in 1. There's one of my 3 curves. There's one of my 3 curves. Now I'm just going to repeat this shape 2 more times so I get 1, 2, 3 of these curves in there, okay? So here it goes, at 4 pi thirds. Pi, I have a maximum. 1/4 of the way it goes through the x. 3/4 of the way it goes through the x. And I get another curve, okay? Alright? Alright, let's do this again. Here and here, right? We're going to take this shape and put it over here. 5 pi thirds is up here, 1/4 of the way, 3/4 of the way. So what we have is 1, 2, 3 curves within the normal 2 pi. That's what the 3 stands for, okay? Capiche?
Yep.
Okay, it's not that hard. You guys okay with this? Okay, let's turn the page, okay? Now, with this one, I'm going to graph it twice. I'm going to do 2 graphs, okay? But with this negative pi force, that's a horizontal shift. Okay? What I'm going to do is horizontally shift it back pi force, okay? So I'm going to take this sine curve and I'm just going to move it back pi force. I'm going to take this sine curve, move it back pi force. That's what I'm doing. So first in pencil, I'm going to draw it in lightly, what a sine curve looks like, and then I'll move it, okay? So let's go and do my pi halves every 4. 1, 2, 3, 4. There's my pi. 1, 2, 3, 4. There's my 3 pi fourths. 1, 2, 3, 4. And there's my 2 pi, okay? I'll go 1, 2. Negative 1, negative 2, okay? So, what am I going to do? Let's take, and first let me just draw in the regular sine. I'm just going to draw in the regular sine curve first, and then I'll move it, okay? So my regular sine curve looks like this, up to 2, right? Down to pi, down there. Okay, there's my normal sine curve. That's this shape right here, but it goes up to 2 and negative 2, okay? Now, I'm just going to take every point and bump it back pi force. So when I bump it back, it's easiest to bump back the 5 important points, the 5 key points. So if I'm going to bump it back, I mean, taking the whole thing's hard, but I know that this point right here is easy to move. This point here is easy to move. This point's easy to move. This point's easy to move. And this point's easy to move, right? Those are the easy points. If I move all of those 5 points back pi force, then I can just draw it in, okay? So pi force is 2 squares, isn't it? Isn't that pi force? Isn't that pi force? If that's pi halves, if 4 squares is pi force, then 2 squares is pi force. So I'm just going to move every important point back 2 squares. So I'm going to go 1, 2. Back pi force, back pi force, back pi force, back pi force, okay? Just draw it in. And I think I'm going to stop here because it's a shortened period anyway. And we'll look at 5 and 6 tomorrow, but let me go ahead and stop it here. And I will